M's going to remind me, so I have to promise. All right, 6th grade. Before we start chapter 9, let me just explain your projects that I passed back. So I know I individually talked with each of you. They are worth 20 points. If you went above and beyond the requirements, I did give you extra credit. They're in the grade book, so it's reflected in there if you get a chance to look at it. If I wrote on yours or told you, make corrections, turn it back in, you are more than welcome to do that. If there's things that you're not sure of why I marked wrong or why I kind of tweaked things, please make sure you talk to me later today or tomorrow morning before class starts. They were really, really good. So at some point, when you are done correcting them or when you are done looking at them, I would like to hang them up, at least for the couple last weeks of school, and I will give them back to you at the end of the year. If you're fixing, adjusting something, that's fine. Just give it to me when you're done. And again, if you're not sure on why I marked something wrong or why I made a comment, let me know. Any general questions on the projects? Jeremy? I got sick of doing check marks, so I just randomly put them as I was reading, Jeremy, and then I would just check one. So if I didn't put any X's on yours or any question mark, they were all right. Some people just had so many equations, it was just a lot of check marks, and I was more so reading and focusing on it, so I wasn't thinking about where I was putting check marks. You get it? Yes. Annalise. I'm not sure what you were going to say. I wish I knew. I'll come back. Go ahead. Sean, you okay? Do you want to go to the nurse and rinse it out? Here. It didn't fall out, did it?
I don't think.
Okay, here.
Yeah, wait, where's the nurse?
Sean, no, I don't think it fell out. I don't see it. Make a right. Go all the way down like you're going towards the gym. It'll be on the right. Okay, you'll find it. Sorry, Annalise. Sean had an emergency. Go ahead. Actually, that's a good question. I put it in as a homework assignment, but I could change that. It's very easy for me to switch it. Yeah, it was homework. Let me think about that, though. That's why I said let me think about that. I could. That's why I said let me think about it. Emma, you guys all asked the same thing, but in different words. I'm almost done with them. So the Chapter 8 test, I did not want to give them back today anyways because I had 3 people still finishing. They will be in the grade book by the end of the day today. That's my priority after class today. So on my prep second period, I should get the rest of them done and into the grade book. Okay? And yes, tomorrow they'll be on your desk. We'll go over them. Emma? That's right. Okay, you can. But if it's a problem, you're going back. Okay? Donatus? Yeah, the tests are good so far, but we'll see tomorrow. Charles, what's up? You had your hand up. Go ahead, ask real quick. Oh, don't write anything. Yeah, don't write anything there. All right, so that was projects. Now let me just give you guys like an overview of Chapter 9. This is our official last new chapter. It kind of makes me sad. I'm going to miss you guys next year. So here's my plan. I'd like to get through this before I leave to get married, which is possible, okay? I'd rather have the sub here and helping you guys with reviews and with practices as well as with the cumulative review. So, hold on. By mid-May, okay, which we're getting there, I'd like to start reviewing for the cumulative exam so we can have time, do a fun review game, make sure you're ready to get an A on that last test, okay? If there's time after that, I'm going to teach you some more interesting and harder pre-algebra and algebra concepts. So we'll see. This chapter's not that difficult, but it is an interesting one. We've talked about real numbers already this year. We're going to really get into right triangles, simplifying radicals, Pythagorean theorem, and more things as well with triangles. So leads us into geometry. It's similar to Chapter 10, but not as many formulas. I think you'll like it. We are going to do the first 2 lessons today. Annalise, what's up? No, I am coming back. I would not do that to you. well, I just can't believe there's only 22 days of school left. So I will tell you more about that when it gets closer. You okay? Basically, Annalise, I have off 2 days before I get married and 2 days after. So it will only be 4 days I won't be here. So it's not going to be forever. We're not going on our honeymoon until June. So I will not abandon you guys, I promise. Emma, unless you want me to. You can, yeah. It's going to be weird for me. It's going to be Mrs. Sefcik. Justin. Aruba in June. Okay, Sefscik. All right, we'll talk about that later. Okay. We need time for weekend stories, so let's get moving. Okay, you guys started the warm-up, okay? 9-1 is, the objective is to find and approximate square roots of numbers. This is really easy. We did this in chapters 1 and 2. That's why I had your warm-up be kind of long, because it was pretty quick. Well, more problems than usual. Okay, so let's start with, there's 2 definitions, okay? Square root of a number n is a number m such that m squared equals n. So square root, you didn't do your, oh yeah, you just got it. Square root of a number n is a number m such that m squared equals n. The weirdest definition ever. All the book is trying to tell you is that 3 squared equals 9, 4 squared equals 16, 5 squared equals 25. 6 squared equals 36. I don't know why they don't say that. We're going to write our own math book and change all this stuff, to be honest. We could. Mary? It is. It is. 3 squared is 9. The square root of 9 is 3, yeah. So if we were to go like this, you can even write it the other way. We're going to get into that today and tomorrow. Okay, perfect square is, oh yeah, that's the next word on there, is a number such that the square is an integer. Perfect squares are something I always have the 9th graders memorize. You have to know what a perfect square is to do well in this chapter. So when you take the square root of something and get an integer, that means it is a perfect square. So for example, square root of 10 is 100, square root of 121 is 11, square root of 144 is 12, square root of 169 is 13. Okay, I could keep going. Okay, when you take the square root of something and you get an integer, it's a perfect square. It's perfect. Adam. Yeah, I'm going to get to that when I get to the chart. Hold on, Denise. Hold off on your trick till we get to it. Annalise, question?
So like by integer you mean
Correct. That's what an integer is. Yep. Okay, radical expression. Let me move this up here, guys. I'm getting there. It's not on your paper. You're going to add it. Okay, a radical expression, wherever you have room, underneath the objective or under the table, wherever. A radical expression is an expression that involves a radical sign. You could have something like square root of 16 plus 1. So, bless you. We know the square root of 16 is perfect. Okay, you get 4. So you'd have 4 plus 1, which is 5. So a radical expression is just an expression that involves a radical sign. So if there's a square root, which we also can call a radical sign, in an expression, it's a radical expression. Annalise. Right here. It's also called a radical. Remember the radical function? Y equals square root of x? Kind of the same thing. Okay, hold on. Let me answer the phone real quick, guys. Hello? Hi. Hi. Oh, that's okay. 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 Right. Okay. Well, okay. Okay. That's fine. Thank you. If they're okay, get back to me. Okay. Thank you. You're the best. Okay. I appreciate that. Have a good one. Bye-bye. Sorry, guys. Anyways, so radical expression, it's going to involve a square root symbol, okay, which you also call a radical sign. The number inside of it is called the radicand. You don't need to know that, but there's a name for everything in math. Go figure, huh? Okay, the table below, you guys had to do for your warm-up. I just wanted you to list all the perfect squares. I want you to write above them. Perfect squares. Okay, Annalise, what's 0 squared? Good. Doug, 1 squared. Emma H, 2 squared. Matt, 3 squared. Melissa, 4 squared. Donatus, 5 squared. Mary, 6 squared. Jeremy, 7 squared. Adam, 8 squared. Justin, 9 squared. Zach, 10 squared. On my desk. 10 squared, Zach. Good, I didn't hear you. Sean, 11 squared. Briar, 12 squared. 13 squared, Emma M. Good job. Adam, 14 squared. Annalise, 15 squared. Doug, 30 squared. 50 squared, Emma H. Good job. Okay, I want to add some. 16 squared. Raise your hand if you know it. Doug, 16 squared. Alyssa. Good, 256. 17 squared. 17 squared. Matt. Good, 289. And write these down. 18 squared. Justin. Good, 324. Charles, 19 squared. Throwing you into this. Do it in your head. 19 squared. 360. What's 9 times 9? Good. Sorry, getting you on the spot there. Okay, 20 squared. Donatus. Good. Okay, so which number is a perfect square? This number or this number? Which number is the perfect square? This number or this number? Emma M? The first one or second one? Good. These are all the perfect squares. If you take the square root of all the ones in red, you're going to get an integer. Okay? Now I want you to add one more list. Okay. I want you to add this list at the top of your, actually, here's where I want you to add it. On this side of your notes, the whole way down, we're listing them as perfect squares first. Okay, then go to this part of your packet. Write them here. At the top, write down perfect squares. Nope. Write them down. We're doing 20. On the cover. Let's go. Matt, square root of 1. Good. Write down square root of 1 equals 1. Emma H, square root of 4. Doug, square root of 9. Annalise, square root of 16. Jeremy, square root of 25. Good. Mary, square root of 49. I did that on purpose. Adam, square root of 36. Good. I'm skipping around on purpose. So your first part of your list should have from square root of 1 down to square root of 49. At the top, you should write down perfect squares. You will have to have these memorized at some point. They're easy. Hold it, Jeremy. Adam. Jeremy, go ahead. You should be writing these all here. Go ahead. No, that's fine. Good. Okay, you can do that way. You can use that. Most of these you should know. When we get into the upper numbers, those are the ones that are a little tricky. Okay, Annalise, go ahead real quick. Exactly. I'm getting to that. Okay, Justin, square root of 64. Good. Zach, square root of 81. Adam, square root of 100. Alyssa, square root of 121. Sean, square root of 144. Charles, square root of 169. Good. Square root of 196, Emma M. Square root of 196. Good. 14. Square root of 225, Emma H. Good. Okay, what should the next one be, Donatus? Correct, so I'm asking you to think about it. Matt, square root of 256 equals 16. What's the next one? Mary. Good, square root of 289, which is 17. Donatus. Good, square root of 324, which is 18. What's the one for 19? Justin. Good, square root of 361, which is 19. Matt, what's the next one? Good, square root of 400, which is what? Good, okay, we're going to stop there. So we could keep going, okay? The list of the first 20 perfect squares, at some point, I'm going to give you a quiz on them. Okay, you need to know them both ways. The square root of a number, but also that number squared, what it's equal to. So, for example, 19 squared is 361. I could also ask you, square root of 361 is what? You could put 19. Briar. Yeah, I'm going to mix them up. Correct. Correct. But you also need to know them the other way. Jeremy. It might be. I'm glad you're thinking like the way I'm thinking. Annalise. Yeah, can't use your calculator and it might be timed. Might be timed. Well, I changed my mind. I didn't lie. I don't lie on purpose to you guys. All right. Okay. Next part of the warm-up. Okay, square root of 222. I want you guys to tell me the decimal and whether it's rational or irrational. Sean. Okay, is it rational or irrational? Good job. 14.9. It's actually 14.899 something, something, something. You can round. It's irrational. Letter B is negative 13. Yes, it's a perfect square. This was part of your warm-up. It's rational, but it's also an integer. Annalise. Yes. No pattern, just keeps going hover at once. Yep. Okay, letter C, Justin. Rational or irrational? Good, irrational. Adam, letter D. Yep, irrational. Emma M, letter E. Rational. Perfect square? Yep. Okay, letter F, Briar. Good. Good job, rational and perfect square. Letter G, Charles, you caught up with us yet?
Yes.
Okay. Go for it. Perfect square? Rational? Good. Alyssa, letter H. Good. Is it perfect? Yep. Questions on the warm-up? Annalise. No, only if a square root is rational, it's always a perfect square. Not any number. Because 12.1 is rational, but it's not perfect. Okay? So you got to watch how you're asking it. But yes, if the square root of a number is perfect, it's rational. Okay, let's flip over. Pretty easy warm-up, huh? Okay, next part. I'm just going to do some of these. Roman numeral number 2 says, evaluate each radical expression when a equals 4 and b equals 16. So letter I, how do we do this? Justin? Good. So we're going to plug a and b in, okay, which is 4 and 16. We're going to multiply them, which is 64. Follow your order of operations. So what is the square root of 64, Doug? Okay. You with us? You writing this down? Okay. So letter I, the answer is 8. All right, Adam, second one, what do we do first? Or letter J, I should say. Good. So we're going to plug in 16 minus 4. We get 12, so we have negative 4. And then in the square root is 12. When there's a number in front of a square root, which I could say is when there's a number in front of a radical symbol, Charles, what do we do with that number?
It means that it's the negative fourth root.
No. If it's the negative 4th root, it's going to look like this. If it's inside it, Charles, just like the cube root's going to look like this. Good. So down here, you would multiply negative 4 times square root of 12. Take your calculator, find the square root of 12 first, and multiply it by negative 4. Matt, what did you get? Good. And I'm gonna round negative 13.86. You can at least.
So if it's another 30-year-old,
Mm-hmm. What do you think? The 12 is inside the square root. It's not negative 4 times 12. It's negative 4 times the square root of 12. Big difference. The square root of 12 is 3 point something. It's not 12. So big difference. Remember when we did square roots back in chapter 2? Okay, big difference. So no, you have to do what's inside the square root first, then multiply it by the number in front. Doug? You can. We're going to get to that in the second lesson. Yep. Okay, letter K, square root of A over B. So square root of 4 over 16. We can actually simplify this. 4 over 16 is really what, Matt? So we could really take the square root of 1/4. This is kind of an interesting one. What's the square root of 1/4? Mary? Yep, 1/2 or 0.5. If you take 1/2 times 1/2, what do you get? Melissa? Yeah, so if you multiply this to check your answer, you're going to get what's inside the radical symbol. Emma? It doesn't matter. Doesn't matter. I'm not picky about that stuff. Okay, let's do one more of these. Letter L. A squared plus B. Okay, A is 4. So we have 4 squared plus 16. What do we do first on this one? Sean? Good. So 16 plus 16. Then what should we do? Justin? Good. So we get 32. So what's the square root of 32, Emma? Good. Questions on that part? All right, let's go to Roman numeral number 3, solving equations using square roots. All right, t squared equals 25. How do we solve this? Emma H. Awesome. To undo an exponent of a 2, you square root both sides. Now this is going to sound confusing. When you square root something, it's the same thing as putting something to the 1/2 power. The square root cancels the exponent of a 2 because t squared to the 1/2 power is just t to the first. You don't need to know what I just said until algebra 2. All you need to know for pre-algebra is a square root cancels an exponent of a 2. So you get t equals 5. Now, could this 5 be anything else? So we know 5 squared is 25. But what other number squared is 25? Doug. Doug. There's 2 5s? No. So, listen. 5 squared is 25. What other number, not the same number, Doug, what other number squared is 25? There is another number. I wouldn't be asking it if there was. Mary, thank you. So, yeah. I'm kidding with you. All right, negative 5 squared is 25 because negative 5 times negative 5 is 25. 5 times 5 is also 25. Good job, Mary. So to write it, if there's 2 answers like this, if you put a plus or minus in front of the 5, this takes care of both answers. So guys, if you look at the board right now, if you're writing plus or minus in front of the number, means that it could be a positive 5, it could be a negative 5. They both make it true. Okay, try n if you haven't already. There's 2 answers, Doug. Charles, did you see the plus minus thing up there?
Yeah.
Okay. Sean. The calculator is stupid, so you have to put it in parentheses. So here's why it does that. The calculator thinks, Sean, that you mean square the 5 first and then put the negative in front. If you put it in parentheses, then it knows that it's negative 5 times negative 5. Don't always believe that thing. Okay. Okay. Sean, did you get letter N? Go ahead, tell me. Good. So negative or positive, which don't forget, guys, you can write it with the plus or minus symbol in front. Either one's true. Adam. I know I did. Okay, this is not time. Okay, go ahead, real quick. Yeah, because everything's labeled in your mouth. Yeah. All right, letter L. This one's a little bit different. What do you guys think we need to do first on this? Emma H, what do we do first? Good, so get rid of the 8 first, divide both sides by 8. So we have n squared equals 16. Then you take the square root of both sides. Annalise, what are the 2 answers? Good, plus or minus 4. Doug, is this a question or is your hand just up? Go ahead. Yep. Yep. Emma. Yes, I'm trying to get there. All right, P. Emma M, what do we do first on letter P? Good, minus 2 on both sides. X squared equals 7. Square root both sides. What's X? Jeremy. You guys are good. Okay, letter Q. Zach, what's the first thing we need to do? Not yet. Good, add 25 first. So we have 11y squared equals 121. Okay, then what, Annalise? Good, divide by 11. Charles, then what? Square root of both sides. So y mat is what? Plus or minus? Good. Yeah, 3, 2. It is 3, 2. Okay. Questions on that? Try the real life example if you haven't already about the book cover. I know this lesson's easy. What'd you say? You mean because it's so easy? Well, we're getting to harder stuff. Just got to give me some time. All right, Adam, what's the answer? Good. So each side is 20 centimeters. Questions on how to get that? Donatus. Oh, I felt like making a capital M. It's okay. Okay, let's flip to page 4 of your notes. Yep, I want to start the next lesson. Just start it. We have time. It's only 8:15. Okay. So, shh, quiet. Flip to 9.2. The title of 9.2 is to simplify radical expressions. So, what this means is we need to talk about how to simplify a radical without using the calculator. In other words, you have to keep the answer exact. Charles, I hope you're not going ahead because you don't know how to do this lesson. Okay. So when you simplify a radical expression, don't change it to a decimal. If it tells you to simplify it completely and keep it exact. I really like this lesson. I think you guys will too. Okay, so here's what it means. When it says on your paper, simplest form in parentheses for square roots. There's a couple things that I want you to jot down where it says simplest form. First one, no factor of the expression under the radical sign has any perfect square other than 1 that goes into it. No factor of the expression under the radical sign has any perfect square other than 1. And I will explain what that means with an example. It'll make more sense. Basically, you do not want to have a perfect square that can be divided into a radical. There are no fractions under the radical sign and no radical sign in the denominator of any fraction. No fractions ever under the radical sign and no radical sign in the denominator of any fraction. What I'm teaching you, well, at least what I'm starting to teach you today, and what we finish tomorrow, you will use this a lot in geometry. Okay, when you simplify things in geometry, they have to be in simplest radical form. Adam, your sister really liked these. I'm sure she'll remember that. Anytime we do a problem like this, she'll be like, "Ooh, I'm going to do it." This lesson can be difficult, but it also can come really easy to a lot of people. So keep that in mind. Okay, so let me show you what all this stuff means. Okay, the product property of radicals says the square root of AB, which Donatus kind of already told us this. The square root of A times B is the same thing as saying the square root of A times the square root of B, where A has to be greater than or equal to 0 and B has to be greater than or equal to 0. You cannot have an imaginary number when you're doing this. I shouldn't say you can't. You can, but we are not going to in this chapter. So for now, it has to be greater than or equal to 0. So I'll rephrase that for you. If it is an imaginary number, you can simplify them, but it's a completely different lesson because you have to have your imaginary numbers in there. I can show you them eventually, yeah. If we had time, I could show you now, but let me show you the basic ones first. All right, so here's an example. If you can take the square root of a number and split it up into something times something, but still equal to 27, you can simplify it without using your calculator. So ready? What is all perfect square that can be divided into 27? Raise your hand when you know. What's a perfect square? Think of our list. 1, 4, 9, 16, 25, 36, 49, 64, etc. That goes into 27. Charles. Square root of 9, square root of 3. So by the product property of radicals, we can split up 27 into square root of 3 times square root of 9. Square root of 9 is perfect. Circle that guy. Okay, he's perfect. She's perfect, whatever you want to call it. The square root of Shiv? Is that what you call it? Shim. Okay. The square root of 9 is 3. Take the square root of it. Leave the square root of 3 there. So, this is perfect. This is completely simplified. Do me a favor right now. Take your calculator. Type in the square root of 27. Hit enter. And then also type in 3 square root of 3. Sean, they're the exact same. So the point of this is you are simplifying a radical expression without using your calculator. It's in simplest form if the number inside here does not have a perfect square that goes into it. Now this is going to be tomorrow's lesson, but I wanted to get the conversation started. Mary, hold on. Shh. I'm going to give you a shortcut to it tomorrow so that that doesn't happen. Annalise. You find a perfect square that goes into it. So remember we just went through our list of perfect squares? 4 is a perfect square. Does 4 go into 27? No. 9's a perfect square. Does 9 go into 27? Yeah. 16's a perfect square. Does 16 go into 27? Can you divide 16 by? No. So you find a perfect square that can be divided into this number. No, the 9. Okay? Because you're changing, remember the product property, Annalise says, the square root of something times the square root of something is still equal to the square root of something times something. You can break them up. Square root of 9 and square root of 3 is still equivalent to square root of 27, but 9 is perfect. Annalise, your homework is not on this tonight. I'm just getting the conversation started. Yep. Mm-hmm. Yep. Doug. Cool. Cool. Jeremy. Why did you prove me wrong? Not nicely. Donatus. Don't, guys, do me a favor. Donatus and Charles, don't go ahead because I need to give you guys some shortcuts. So don't go ahead and don't do the variable ones. Charles, you're going to have to redo them all because there's some yeah. All right. Homework and then weekends. Thank you. Okay, your homework for tonight is going to be practice 9.1. Shh, quiet. 1 to 32. Shh, hold on. Well, instead of saying all, I put the numbers because some people used to just look at the first page. And then also, in your homework packet, page 143, 1 to 10. The homework won't take long. Yeah, it's not. It's just 9.1.
It's just like square roots.
Yeah. Yeah, and now listen, guys, before we talk about weekends, the homework is only on 9.1. It's not on what I just did the past 5 minutes. Okay, I'm going to do that all tomorrow. So your homework is only on the beginning stuff that you're like, Emma H. said, why are we learning this now? Or whoever said that. Okay, was it you? All right, so let me stop this. Are you guys good with homework? Okay, weekend stories. If you're going to share something, pick one thing.